Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Today, we are moving beyond polynomials and exploring the derivatives of trigonometric functions, which describe everything from sound waves to planetary orbits. On the screen here, you will see the three core derivatives that we should aim to remember. Recall that we've actually proven this one in a previous video in the limits playlist. And this one was the check your understanding problem in that exact same video, which means the only brand new one here is the derivative of tangent x, and that is equal to secant squared x. Now, before we move on any further, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So now that we have these three new derivatives at our disposal, let's take a look to see if we can derive the derivative of cosecant x. So we're going to start with the derivative, which is d by dx, of our function, which is cosecant x. So this is equal to, recall that cosecant is just the reciprocal function of sine, which means this is equal to the derivative of 1 over sine x. And now, because we have a fraction, 1 over sine x, we can go ahead and use our quotient rule. So the quotient rule says this is going to be equal to the derivative of the top function. So derivative of 1 is just equal to 0, since derivative of all constants is equal to 0. So we have 0 times our bottom function, which is sine x, and then we subtract our top function, which is 1, multiplied by the derivative of our bottom function. But we know that the derivative of sine x is just cos x. So this is 1 times cos x. And then this is going to be over our denominator squared. So that is going to be sine x all squared. So essentially what we have done here is we applied the quotient rule. Okay, so now let's go ahead and simplify this a little bit. So this is going to be equal to negative cos x over sine squared x. And now we can simplify this a little bit further, since we can take one of these cos x over sine x and simplify that to cotangent x. So what I mean is that we are going to split our sine squared x into sine x times sine x. So you can think of this as negative cos x over sine x. And now we're multiplying this by another 1 over sine x. So now the negative cos x over sine x is going to turn into negative cotangent x. And the 1 over sine x is just cosecant x. So the derivative of cosecant x is negative cotangent x times cosecant x. So notice how we only needed one of the core three derivatives from above in order to generate this one. Now similarly, we can generate the derivatives of the other two trig functions. So the derivative of secant x is secant x times tan x, and the derivative of cotangent x is negative cosecant squared x. And if you're so inclined, feel free to verify those yourself. So now we have the 6 essential trig derivatives that we'll be referring to for the remainder of this playlist. So now let's take a look at combining those trig derivatives with everything we've learned before. Here we want to find the derivative of 3ex times sine x. So we start by writing our d by dx of our expression, which is 3e to the x times sine x. So notice how we can just pull the 3 in front of our derivative. That'll make things a little bit easier, because then we can work with smaller numbers when we're doing our product rule here. So we have e to the x times sine x. So here we can use our product rule. Our first function is e to the x, and then our second function is sine x, which means this is going to be equal to 3 times the derivative of e to the x is still e to the x, multiplied by our second function, which is sine x. And then we add our first function, so that's e to the x, multiplied by the derivative of the second function, and the derivative of sine x is cos x. And now we can factor out the e to the x, So that means our final answer here is going to be 3 times e to the x times sine x plus cos x. Now for our last example of this video, we want to find the equation of the tangent line to this function f of x at x is equal to pi over 2 and at x is equal to pi over 4. So we've done this a couple of times now. We know that in order to find the tangent line, we need a point and we need the slope. And to find the slope, we need to find the derivative. So let's start with that. We have f prime of x is equal to, now the derivative of x is equal to 1 using our power law, and the derivative of cos x is negative sine x. So f prime is equal to 1 minus sine x. And now we're ready to find our slope and our point for each of those x values. So the first one, we're going to say that is at x is equal to pi over 2. So then our point here, we have the x value already. X is equal to pi over 2. Now to find the y value, we just have to substitute this x value into our original function f. So f of pi over 2 is equal to pi over 2 plus cosine of pi over 2. And cosine of pi over 2 is just equal to 0. So which means f of pi over 2 is pi over 2. So our point here is pi over 2 comma pi over 2. And then our slope here is going to be f prime of pi over 2. So that is going to be 1 minus sine of pi over 2. And sine of pi over 2 is equal to 1. So therefore our slope, we'll call that m, that is equal to 1 minus 1, which is 0. So since the slope is 0, then that means the equation of the line is just y is equal to the y value of the point, which is pi over 2. Okay, so this is for our first point. We're going to do the same thing for the other x value. So at x is equal to pi over 4. Okay, so we're going to do the exact same thing. First, we're going to find the point by substituting in the x value into our function f. So f of pi over 4 is equal to pi over 4 plus cosine of pi over 4. Now cosine of pi over 4 is 1 over root 2. So therefore, our point is pi over 4, comma, pi over 4 plus 1 over root 2. So those are the x and y coordinates. Next, we're going to find our slope. And to find the slope, we're going to substitute in our x value into the f prime function. So f prime of pi over 4 is equal to 1 minus sine of pi over 4. And sine of pi over 4 is also 1 over root 2. So therefore, our slope, m, is equal to 1 minus 1 over root 2. And now we're ready to write down the equation of the tangent line using the point-slope form. So that's going to be y minus the y-coordinate of the point, which is pi over 4 plus 1 over root 2. And this is equal to the slope, which is 1 minus 1 over root 2, multiplied by x minus the x-coordinate of the point, which is pi over 4. And you can just leave your answer like this. There's no need to expand it out. So therefore, we have the equation of the two tangent lines. At pi over 2, the tangent line is y is equal to pi over 2. And then at pi over 4, the equation of the tangent line is this one right over here. And now let's do a quick recap of what we covered in this video. We went over the derivatives of the three main trig functions, which are sine, cosine, and tangent. We also looked at the derivatives of the three reciprocal trig functions, but you only need to remember the three main ones because we can derive the derivative of the three reciprocal trig functions using the three main ones. And we also learned how to use these rules in conjunction with the rules we've learned before. And now it is your turn to give this a try. Can you find the equation of the tangent line to the function f of x here at x is equal to pi over 3? Make sure to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.